Welcome to SwiftForge, a proof of concept built to automate scenario generation for financial messages. I am Sachin Gupta and I have developed this with Copilot to address a common challenge in trust automation: how to efficiently and accurately generate Gherkin scenarios from complex XML based payment messages like PAX8 and CAMT54. Let's go to the next slide. So the test scenario creation in the payments domain is traditionally manual, slow, and error prone. These ISO 20022 formats like PAX8, PAX9, CAMT53, and CAMT54 are highly structured and vary across rulebooks. This leads to coverage gaps and makes compliance harder, especially when rulebooks evolve. SwiftForge rethinks this process by using generative AI to automate scenario creation while maintaining traceability and auditability. SwiftForge offers a streamlined experience. You upload an XML, select the message type, and the system generates and exports Gherkin scenarios. Behind the scenes, a team of modular agents, orchestrated by Autogen, which is a multi agent architecture platform provided by Windows or Microsoft. And these multi agents generate, enhance, review, and export scenarios. Every run is tracked in MLflow and the output is compatible with Behave, making it easy to integrate into existing type pipelines. So here we have the architecture diagram for this. So it starts with a Streamlit UI where users upload XML messages like Apex 8 or a CAMT54. Once submitted, Azure machine learning triggers the orchestration pipeline. At the core is the Autogen framework, which manages a group chat of specialized agents. The user proxy initiates the conversation and routes tasks to four modular agents. The generate agent creates base Gherkin scenarios using extracted fields from the input files. The enhance agent adds validation, edge cases, and business logic. The review agent checks for structural correctness and logical consistency. And finally, the export agent formats the output into behave compatible feature files. The output file contains the scenarios generated by each of the agents. AI agent interactions are powered by Azure OpenAI's GPT-5 nano model via chat completion. The entire run is tracked in MLflow, capturing metrics like scenario count, token usage, and artifacts for audit and traceability. The result is a fully automated, explainable, and scalable test generation pipeline. Hi everyone, let's go through the demo. This is the UI that I have built with Streamlit. It's a very simple UI. We have covered the tech stack here. We have covered the agents that are being called here, and then kind of indicating what we are tracking in terms of MLflow integration. Right. So the first, let's take up a PAX8 file. Let me show you a sample file that we have. This is PAX8 sample file that we have, which will be parsed, and test scenarios will be generated based on this. Okay. So let's do this. Uh, let's browse the file PAX8. Alright, so now we need to click on the run orchestrator. So all the I have not integrated with CI. Largely, I want to build these POCs in order to run them, and I run them locally in order to save some time. Right. So CI can easily be built in to each of the POCs. Okay. Alright. So let me show you while the orchestrator is running. It would take a minute to for all the agents to run and then prepare the scenarios. In the meantime, let me show you what we have deployed in Azure. Okay, so first we have this Azure machine learning workspace, and our studio is accessible via this, right? So this is the machine learning studio where we are tracking each and every run and each and every feature file that is getting created along with how many scenarios are getting created. So this shows you the details of the past runs, right? So we ran it for multiple formats. So let's look at the recent one, right? And if you look at the output and logs, right? So here you see a feature file in its statistics JSON format, right? So this is the feature file. All the agents output is being captured in this file, right? The one that we will be able to download via UI is formatted. It has a new line in between the scenarios, right? And if we look at the current run, right, this is what is running currently in the jobs, right? Has it completed? Let's check. I think so. Okay, let's go back to our UI. Okay, it is still running. It's not completed yet. Uh, okay, so what else do we? And okay, so this was the machine learning, and then we also had deployed an LLM model, which is GPT-5 Nano, and this is the driving force behind all the multiple agents that we have, right? So GPT-5 Nano is a pretty useful model. So it was launched recently, but yeah, that is what we are using, and you can use any model that you want. Okay, so our orchestration got completed. The scenarios have been created, and and there are 8 scenarios that have been created. So let's look at the feature file. Okay, so dot 1758. Let me open this feature file in Notepad. 1758. Okay, so here you see a much better format for generate agent, export agent. So the output of the export agent is the final scenarios that we need. And if you can look at it, right, there are a lot of details captured in these scenarios, right? So they can be modified to fit a certain format. All right. So I'll include, and I have stored this POC code in GitHub. Let me show you that. All right, so this is where we have saved the code for the entire POC, right? And it has a detailed set of instructions on what we have done, which you can review. Right? Thank you.